Welcome to our lesson today. My name is Purity Anzelimo, and our today's topic is differentiation. And in this lesson, we are going to cover the last bit in this topic, that is differentiation, and our last part is maxima and minima. Maxima and minima. In the previous lesson, we were looking at applications of differentiation in calculation of distance, in calculation of velocity, and in calculation of acceleration, whereby we said velocity is ds, where s is the displacement, all over dt, where t is the time. Then we said acceleration is dv, all over dt, where v is the velocity and t the time. And I remember when we were looking at this velocity acceleration, there's something that we said that we are going to apply in maxima and minima. We said when we want to calculate the maximum velocity, at maximum velocity, we said therefore that the ds all over dt is equal to 0. At maximum velocity, ds all over dt is 0, meaning that the gradient is 0. It is at the turning point. Again, at the maximum acceleration, also dv all over dt is equal to 0. Now, we are in maxima and minima. At maxima and minima, the gradient function is equal to 0. That is for maxima and minima, the gradient function is 0. The gradient function is 0. It can be maybe the maximum area. It can be quantities like maybe area. It can be volume. It can be the velocity, acceleration, all these. So for maximum area, the gradient function is 0, or the equation that will give us the area is equal to 0. And also for minima, either for maxima or minima, the gradient function is 0. Because remember we said at the maximum and the minimum point, maximum and minimum point are turning points. Remember we said that maximum and minimum points, we said that they are stationary points. These are stationary points. They are stationary points. And these stationary points, their gradient of a stationary point is equal to 0, both for maximum and minimum. So we are going to do some examples so that you can understand more how to calculate maximum and minimum. That is, it can be area, volume, acceleration, velocity, or any other quantity. So I'd like us to do the following examples so that you understand it better. Question number 1, a farmer, can start with this, a farmer has 100 meters of wire mesh, 100 meters of wire mesh to fence a rectangular enclosure what is the greatest area, he can enclose, with the wire mesh. So that's the question. Maximum area. A farmer has 100 meters of wire mesh to fence a rectangular enclosure. What is the greatest area he can enclose with the wire mesh? So he is using the 100 meters of wire mesh to fence a rectangular enclosure. Then we are asked to calculate the greatest area he can enclose with that wire mesh. So we need to consider this is the rectangular enclosure. This is rectangular. So if we can take x to be our length, or any letter, like even y. So we can take x, this is our length, and we are told that the length of the wire mesh is 100 meters, so we can take this one to be x meters. And because all of it will be 100 meters, it simply means that if our length is x, again the other side will be x meters. We need to calculate the value for the width. So in our case, we are going to have the width as we have 100 is equal to this side x plus x, then plus the two widths. We have this side and this side, and therefore we are going to have then plus the width plus the other width. This one is going to give us the 100 meters. And therefore, when we want to get the width, therefore, it means that width, therefore, will be equal to the 100 minus x plus x, which is 2x. And because these are 2, and we want to get 1, we divide this by 2. And therefore, the width will be, this is the same as 100 all over 2 minus 2x all over 2, which will be equal to 50 minus x. So the width is 50 minus x meters, and this is x meters. And therefore, we need to get the equation for the area. We get the equation for the area. So we need to get the area. So our case for an area, that is for a rectangular enclosure, the area is given by length times width. So our area is length, our length is x, and our width is 50 minus x. And therefore the area will be 50x minus x squared. So area is equal to 50x minus x squared. And the question is asking us to get the greatest area he can enclose with the wire mesh. And we have said that for maximum, for any maximum, the gradient function is 0. So we need to come and say, therefore, at the maximum area, therefore, the dA all over dx should be equal to 0. It should be equal to 0. So we are going to equate that equation to 0 so that we can get the value of x. Then we can be able to calculate the maximum area. Therefore, we get our dA all over dx. We are differentiating that equation for area with respect to x. So we are going to have, this is 1. So we have 50x, 1 minus 1, then minus 2x squared minus 2. So we end up getting 50 minus, this is minus 1. So we have 50 minus 2x. And therefore, we have our dA dx, our dA all over dx equal to 50 minus 2x. And we have seen that for maximum, dA dx is equal to 0. So we equate dA dx to 0. So we have 0 is equal to 50 minus 2x. And therefore, when we take 2x to the other side, we have 2x is equal to 50. And therefore, x will be divided by 2, that is 25 meters. So x is 25 meters, that's the length. The length is 25 meters. We have this as 25 meters, so we have the length as 25 meters, and the width is 50 minus x. So 50 minus 25, again we have it as 25 meters. And therefore, the maximum area will be given by the length times the width. And our length here is 25 meters. The width is again 25 meters, which will give us 25 times 25, that is equal to 625 square meters. So that gives us the maximum area. So we have seen that at maximum or at minimum, it simply means that the gradient function is equal to 0. So we need to get the area, the equation for the area, which is this. Then after getting the equation for the area, when we get the gradient function, we equate it to 0. We find the value of x. Then with the value of x, we can now be able to get the area. So therefore, the area will be equal to 625 square meters.